All right, so we have one last lesson in Unit 2, and this is where we are going to be going over multi-step equations. So this will not be as short as the last one, but hopefully with the last lesson, that will make this one a little bit easier. So all we are doing in this is that we have to isolate the variable and solve using the concepts of balancing the equation, which is just making sure that both sides remain equal to each other. So it's just using the fact that whatever you do to one side, you have to do to the other. And if you want to get rid of a term, you have to do the opposite operation of what you see. So if you see in the case of example A, +3, you are going to subtract 3 from both sides. Now, when we are doing a multi-step equation, all that means is we're taking the nice, easy, simplified ones from up here, where it's just subtract 3 from both sides, and we're adding in a secondary step. So for example, if I look here, we'll go with our -3 that we just saw. That goes to 0, so which means I get 2x is equal to 17 minus 3, and 17 minus 3 is 14. I can see that x is still not on its own. I have not isolated x. I've done one step, but this is a multi-step equation, so I have to do another step. To isolate x and get it on its own, I can see that it's 2 times x, so divide both sides by 2, and I will get x is equal to 14 divided by 2 is 7. Now, if I use the other example that I have here, or we've got a couple examples, I'm going to subtract 6, or just make it -6. So -3y is equal to -12 minus 6, which is -18. My second step is I want to get rid of my -3, so I'm going to divide both sides by -3. So y is equal to -18 divided by -3 is -6. If we go on to example C, I can see a -4 here, so I'm going to bring it across the equal sign and make it +4. So I will get 2m is equal to 6 plus 4 is 10. I can see that 2 times n, so I want to divide because division is the opposite of multiplication. Whatever I do to one side, I must do to the other. So m is equal to 10 divided by 2 is 5. This side here, we have to remember that there is brackets, a division bar, also groups. This was from one of our review lessons from Unit 1, which means I have to get rid of my 7 first. So it's divided by 7, so I'm going to times it by 7, so that 7 and 7 cancel out. And times this side by 7. I don't know why I'm staying so far zoomed out when I can zoom in. But that will give me 2y is equal to -4 times 7 is -28. Yeah. Now I have 2 times y. I'm going to divide it by 2 so that 2 and 2 cancel out. Whatever I do to one side, I have to do the other. So y is equal to -28 divided by 2, which is -14. I can see on this side here that I have a fraction times a variable is equal to 6. I can do this a couple of ways. I know that it's multiplied, so I'd have to divide by the fraction, which means on the other side, I would multiply by the reciprocal of the fraction. Or I can look at it as -2r over 5, because this goes up here with this, because it's technically saying r over 1 is equal to 6. This way, I'm going to multiply both sides by 5 to get rid of my 5. Then I will get -2r is equal to 30. -2 divided by +2. -2, those cancel out over -2. And r will equal -15 because 30 divided by 2 is -15. I am just going to show you this one another way as well. Or let's have -2 over 5 times r is equal to 6. If I divide by -2 over 5, divide by -2 over 5, I will get r is equal to 6 divided by -2 over 5, which is r is 6 times 5 over -2 equals 6 over 1. 6 times 5 is 30 over -2 is equal to negative 15. You can see that both ways I got the same answer. There are lots of cases where that will happen in math. I am okay with either one because they both follow proper mathematical processes and they both get you to the same answer. Okay, so let's now go on to F. I can see that I have my negative 9, so I'm going to bring it across the sign and make it positive 9, which means t over 5 is equal to minus 3 plus 9, which is positive 6. Now I have it divided by 5, so I'm going to times both sides by 5, and I will get t is equal to 30. Awesome. Now, if we move on to examples 2, we're looking at multi-step equations that require you to collect like terms. Now, when we do this, we kind of want to bring them to opposite signs of the equal sign. So you can do this in a couple of steps, or you can do it in one step. I'm going to show the first couple of examples, or the first example, in multiple steps, so you can see exactly how it's occurring. But I know that I want to bring this over to this side. It's a positive, so I'm going to minus 4n here. I will get negative 3 equals 27 minus 6n plus 4n, but these are like terms, so I can collect them. I will get negative 10n. Now I have this 27 here that I want to get rid of. I'm going to bring it to this side and make it minus, so it would be minus 27 minus 3 is negative 30 is equal to negative 10n. Now I can see that I want to get rid of this negative 10, so I'm going to cancel it out by dividing it by negative 10. Whatever I do to one side, I must do to the other. So I am going to get 3 is equal to n. Awesome. Now if we move to example C, we have a very similar process. I can collect these two like terms here, which will give me negative 2k. What I'm going to end up doing is that means I have 5k minus 3 is equal to 11 minus 2k. I am going to bring my negative 2k over here and make it a plus, so it's plus 2k. 5 plus 2 is 7k minus 3 equals 11. I'm going to bring this over here, make it a plus, so it's plus 3. 7k equals 11 plus 3 is 14. Now I have 7 times k, so I'm going to divide both sides by 7. So k is equal to 2. Awesome. Now we are going to do multi-step equations that involve brackets. What you will notice is that we are slowly building up to harder and harder equations, and we are essentially moving in the opposite order of BEDMAS. I'm going to end up writing that at the bottom after we do the last couple of ones. So the first thing that I'm going to do here is I'm going to use my distributive property. So I will get 3x plus 12 is equal to 6. Now this is a little bit easier. I can see a positive 12. I want to bring it over here and make it negative, so I will get negative 12. So 3x is equal to 6 minus 12, which is negative 6, because these are like terms. 3x is equal to negative 6. I want to divide this by 3 so that my 3 and 3 cancel out. Whatever I do to one side, I must do to the other. So I will get x is equal to negative 6 over 3, which I can simplify down to negative 2. Apparently, I'm running on the trend this unit of having my pen die. Now, if we move on to example B, again, we have brackets, which means we have to use, that was a terrible arrow, distributive property, which means this is 5n plus 5 times 3 is 15 is equal to 2n minus 6. Now I'm going to attempt this in one step. If you understand it in one step, you are more than welcome to do it in that way. If you don't, do not stress about it. But what I'm going to do is I'm going to bring this over here and make it negative. I'm going to bring this over here and make it negative as well. So I will end up with 5n minus 2n is equal to negative 6 minus 15. Now I can combine my like terms. So 5n minus 2n is going to be 3n. It's equal to negative 6 minus 15 is negative 21. I can see here that I have times by 3, so I'm going to divide to get rid of, divide to get rid of. So n is equal to negative 21 divided by 3, which is negative 7. And one last example of this one, we're going to use distributive property again. So negative 2 times 2w is negative 4w. Negative 2, remember that negative stays with it, times 10 is negative 20, is equal to 2 times w is 2w, 2 times 2 is 4. Now again, one last time, I'm going to try and combine this all in one step, which means I'm going to bring this to this side and make it negative, and this to this side to make it positive. It does not matter which side you have your variable on, as long as you change the signs appropriately. I typically prefer to work with a variable that is a positive number, not a negative number, so I will normally just move it to whatever side, make sure that it's positive, but it is completely up to you. But if I rewrite this, I will get negative 20 minus 4 is equal to 2w plus 4w. And this is why I typically do it this way, is that's going to equal positive 6w, which means we don't have to divide or multiply by negative numbers, just makes everyone's life a little bit easier. So I will get negative 24 is equal to 6w. And this is just combining like terms. Combining like terms. I'm then going to divide both sides by 6 so that I get w is equal to negative 24 divided by 6, which is negative 4. Awesome. And we have two last types of multi-step equations that we are going to do. First one is going to be one that is involving fractions. So first thing that we see is I have p over 2 plus p over 3 is equal to 4. The second you see fractions, you want to find your common denominator. In this case, it's just going to be 6, because 2 times 3 is 6, and 3 times 2 is 6. All right, so as I was saying here, what we want to do is times by 3 times by 3. This side we're going to times by 2 and times by 2, so that we get 3p over 6 plus 2p over 3 is equal to 4. Nope, that is not right. I'm forgetting one step. Bear with me, I'm apparently too tired and have not had enough coffee yet. But the one step that we did miss is we have multiplied this side through to get a common denominator of 6. I almost went and just put that this was equal to 4, but then we have made this unequal to each other because I have not kept this equal sign the same. As I kept repeating last lesson, whatever you do to one side, you must do to the other, which means I also want to multiply 4 by 6 so that I end up getting, I believe it is 24, yes, over 6. And this is supposed to be a 6 as well. Now that will work out. So if I combine these two like terms together, I will get 5p over 6 is equal to 24 over 6. Now, I don't like this fraction here, so I'm just going to multiply both sides by 6. So that I get 5p is equal to 24. Now, if I take a look, my final step to getting p on its own is to divide by 5. Divide by 5, and I will get p is equal to 24 over 5. I cannot reduce that down at all, and I lost half my square, but that will be our final answer. Over here, I have a fraction, and I need to multiply that through. So what I'm going to end up doing in this case is making sure that I can get rid of it as quickly as possible so that we don't have to work with fractions as much. So when you are working with fractions, this is another one where we have two main ways that we can do it. This is one way where I'm going to find my common denominator. The other way here is that I have a fraction there and I need to get rid of this. So I'm just going to multiply everything by 3. Oops. This means my 3 and my 3 will cancel out, and I will get 2. Y plus 5 is equal to 12. Now I'm going to use distributive property, and I will get 2y plus 10 is equal to 12. Now we're just back to our standard multi-step equations. I'm going to bring my positive 10 to the other side and get negative 10, so that 2y is equal to 12 minus 10, which is 2. And then I'm going to divide both sides by 2, so I can isolate y on its own, and I will get y is equal to 1. And I am done with that question. And we have one last example that we are going to do, which is solving equations with binomials as their numerators. So this is just a continuation of fractions, but now the numerator of my fraction has a binomial. Now we're going to do the same exact thing that we've done previously. We're going to find our common denominator, but for this example, I'm going to mix this method and this method together to make it a bit easier to see the different options that you have. In this case, 3 and 4, a common denominator would be 12. So I'm going to multiply by 12, multiply by 12, and multiply by 12. When this happens, I can see that 12 is divisible by 3, and that would give me 4. 12 is divisible by 4, and that would give me 3. So I will get 4a minus 2 minus 3a plus 4 is equal to 60. Now I'm going to use distributive property, and I will get 4a minus 8 minus 3a minus 12 is equal to 60. I can combine my like terms, and that will give me 4a minus 3a is just a, minus 8 minus 12 is negative 20. I don't know why I changed the color on that one. Negative 20 is equal to 60. I'm then going to bring this over to this side and have it be plus 20. So a is equal to 80. So that is all we have for this unit. You are good to start working on the review. Do not forget that you have your unit test coming up as well. Make sure you double check the date and ask any questions beforehand.